Hello friends, here in this video we are going to see a problem on tetrahedron. Let us get started. A tetrahedron of 60 side is having one of its edge parallel to VP and inclined at 45 degree to HP, while a face containing that edge is inclined at 30 degree to VP. Draw its projections. So this is the question. Whatever the conditions are there in this question, I'll explain it. First of all, by reading this we have understood that the type of solid is a tetrahedron. Now what is tetrahedron? Tetrahedron is that solid in which all the faces are in the form of equilateral triangle, even the base is in the form of equilateral triangle. So here I'll quickly draw the diagram for that. So here we have a diagram of a tetrahedron, which is a solid in which all the faces are in the form of equilateral triangles. Here the base is in the form of an equilateral triangle, and all the base corners, it has three base corners connected to a common vertex called as apex O. These are the slant edges, and it has triangular faces, and even the base is in the form of a triangular base, and all are equilateral. Means they are all equilateral triangle. It is given that tetrahedron of 60 side is having one of its edge parallel to VP. It means the entire tetrahedron is in VP. Now one of its edge is parallel to VP, so for that I will be explaining the condition. The side of base is given as it is 60 side tetrahedron. I'll measure this distance 60 drawing an arc, keeping it onto the other side, cutting this arc. Then here I get the intersection point. Joining it will give me the tetrahedron, which looks like an equilateral triangle in the front view because it is in VP, so it will be seen as an equilateral triangle in the front view. Now after this, when we are looking from front, it has triangular faces. So those triangular faces are connected to a common apex. For that, I'll take half of this distance, which is 60 half of this side, to form the midpoint, then joining it to the opposite corner. Next, taking any one of the sides, taking its midpoint and joining to the opposite corner. Now wherever these two lines intersect, that gives us the apex. I'll make it dark. So in this way the tetrahedron will look from the front, resting on its edge. This edge will be parallel to VP. Now taking this as the initial condition, I'll start completing the solution for this. So here we have XY line, HP and VP. Now since it is resting in VP, having one of its edge parallel to VP, so I'll use this initial condition and draw the tetrahedron here. It means the complete tetrahedron is in VP. I'll draw a light vertical line. Over that I'll mark this distance 60 because here I have drawn the tetrahedron with its original dimensioning. Taking this distance as 60 mm, marking it, then drawing an arc here. Next I'll cut this arc from the other side or from the other point. Wherever these 2 points intersect, I'll join it. Next, again I'll take midpoint of any one of the sides, and that already I have marked here. Taking this distance, marking it on one side, marking it on other side, and then joining it to the opposite corner. So here we get the apex. I'll say it is O dash. Next, this is the front view of the tetrahedron when it is resting in VP. So now, here I have joined all the corners to the apex, forming the slant edges. Next, I'll give it the notation. This will be 1 dash, here 2 dash, this is 3 dash. It means this tetrahedron is resting on an edge 1 dash 2 dash. Projecting it in the top view, from the top if we are looking, edge 1 dash 2 dash will look like a point, and here I have that point. It is 1, 2. Next, I'll be projecting the apex with a light line, then projecting this point 3 dash. Now when we are drawing a tetrahedron, always see that here we have completed the front view. For top view, we have to draw the tetrahedron in such a way that take the distance, which is 60 mm, distance of the side given of the tetrahedron, then measure that distance from the corner, not from the edge. That is, here if we see 1 dash 2 dash shows an edge, whereas 3 dash shows the corner. So here there is 0.3. So taking the distance 60 mm, keeping it on 0.3, cut this line which is passing through the apex. Although here it is looking like an equilateral triangle in one view, but in the other view it won't be appearing as an equilateral triangle because the shape will change. When we are looking from top, we are going to get an apparent shape of this tetrahedron. When we are looking from front, we are getting the true shape, so that is why it is an equilateral triangle. So here I'll connect the points. So this gives me point O. Now after drawing the front view and top view, I'll make it dark. Here this shows the axis of the tetrahedron. Now this is the initial condition. After this I'll read the question again. A tetrahedron of 60 mm side is having one of its edge parallel to VP that we have drawn and inclined at 45 degree to HP. So inclination with HP is given, that will be seen in VP, and inclination with HP is denoted as theta. So theta is 45 degree. Next, while a face containing that edge is inclined at 30 degree to VP, inclination with VP is denoted by phi, and phi is 30 degree. Inclination with VP will be seen in HP, and if we see here, the inclination is given of, while a face containing that edge is inclined at 30 degree to VP. It means the face, if we see, containing the edge, that edge on which it is resting, it is 1 dash 2 dash, and that contains a triangular face 1 dash 2 dash O dash. So this triangular face, when seen in the top view, is at this location, which is O12, and it has to be made inclined at 30 degree to VP, so it will be seen in HP. So the next condition will be making this triangular face inclined 30 degree to VP, drawing the tetrahedron. After that I'll use the condition which is given, it is 45 degree to HP, which will be seen in VP. That will be our last condition. So let us get started with the second condition, where I'll make this triangular face inclined at 30 degree to VP, seen in HP. Next, I'll measure this edge, which is from O up till 1 to 2, and then marking it over here. keeping this point, marking this distance here. So that gives me the edge which is O, and here it is 1, 2. Next I'll copy this tetrahedron over here. For that, since it is inclined, now I require the remaining edges. So for that, from the apex up to point 3, I'll measure this distance. And drawing a light arc from this apex, then measuring the base from 1 to 2 up to point 3, cutting it. So here I get that inclined tetrahedron. Now here I'll mark point 3. Then for the axis, I'll take the distance from point 3 up to this center. Marking the distance. Making this inclined tetrahedron dark. Now, this is the top view of the tetrahedron in which the triangular face is inclined with VP at an angle of 30 degree. Now I'll draw the front view for it, and for that observer is here. So as an observer, those points will be projected first which are closer to the observer. So if we see from here, point 3 is closer, so that will be projected first. Point 3 dash from the front view. Wherever they intersect, that gives me point 3 dash. Then point O of the apex. Point O dash from the front view onto the same line as 3 dash. So here we have point O dash. Next, points 1 and 2 will be projected. With a light line, projecting 1 dash first. Then 2 dash. So here I'll get point 1 dash and point 2 dash. Now joining the outlines in the proper sequence, because outlines are never going to be hidden. Joining O dash to 1 dash, then O dash to 2 dash, next 2 dash to 3 dash, finally 3 dash to 1 dash, so after reaching here I'll make it dark, all these edges. O dash to 1 dash, then O dash to 2 dash, similarly in order. Then as an observer, if we are looking from here, the edge O to 3 slant edge is visible, so it should be made dark. Joining O dash with 3 dash, then edge 1 to 2, that is 1 dash 2 dash, is going behind the observer, so it should be hidden. So drawing it with dotted line. Next, this is the front view of the inclined tetrahedron, in which out of the 3 triangular faces, triangular face O dash, 2 dash, 3 dash, that is visible, O dash, 1 dash, 3 dash is visible, and the triangular face 1 dash, 3 dash, 2 dash going behind the observer, so it is hidden. Then we can say that this 1 dash, 2 dash, 3 dash is nothing but the base of the tetrahedron, which is denoted here, and here is the triangular face, which is O dash, 1 dash, 2 dash, that is also hidden. So this is the second condition. Now in the third condition, it is given that one of its edge parallel to VP and inclined at 45 degree to HP. So the same edge which was parallel to VP, that is 1 dash, 2 dash, now this edge will be made inclined at 45 degree to HP, and that will be seen in VP. For that, I'll draw a light line inclined at 45 degree. Drawing a light line through it. Then here the angle is 45 degree with HP seen in VP. Copying this entire tetrahedron on this side. So taking the distance from H2 dash up to 1 dash. Marking it on this side. Now the tetrahedron will be tilted in such a way that 1 dash is here and 2 dash is on the other side, so that gives me 1 double dash, and this is 2 double dash. Then I have to copy this entire tetrahedron here. For that, I'll mark the distance of this center line O dash 3 dash. So onto it, I'll mark the distance of this center line. Next, this line is perpendicular to 1 dash 2 dash, and for that marking 90° over it. Then measuring the distance from this edge 1 dash 2 dash up to point number 3. So point number 3 will be below this. So measuring this distance of point 3, keeping it over here and marking it on this side. So that gives me the point 3 double dash. Now after getting 3 double dash, on this same line there is O dash, which is the apex. For that I'll take the distance from 1 dash 2 dash, this edge up to the apex. And this gives me O double dash. Then joining all these points with the help of light lines first. O double dash to 2 double dash, then 2 double dash to 3 double dash, then 2 double dash to 1 double dash, next 1 double dash to O double dash, copying it in a similar manner. Edge O dash 3 dash is a dark line. Then the outer edges, one double dash 2 double dash will be a hidden line because that edge was hidden in the second condition, and same edge we had taken and made it inclined at 30°. Here it is at 45° with HP. Now this is the inclined tetrahedron in which 1 dash 2 dash is 1 double dash 2 double dash inclined at 45°. Now this is the front view of that tetrahedron. Next I have to draw the top view, and for that observer is here, fixed here. So if we are observing the tetrahedron from the top, those points needs to be projected first which are closer to the observer. So if we see here O double dash is closer, that will be projected first. Then point O, that is apex from the top view. Wherever O double dash and O intersects, that gives us point O in the top view, apex. Next 2 double dash is closer to the observer. Then point 2 will be projected from the top view. Wherever 2 double dash and 2 intersect, that gives us point 2. Then point 3 double dash. Projected light, and here we have point 3 in the top view. Wherever 3 double dash and point 3 intersect, that gives us point 3. Next point 1 double dash. And here we have point 1 and 2 onto the same line. So wherever point 1 double dash and 1 they intersect, that gives us 0.1. Now joining all these points in the proper sequence, first of all the outlines, they will never be hidden, and as an observer here, O double dash 2 double dash, that is visible, or we can say that the complete triangular face O double dash 1 double dash 2 double dash is closer to the observer, so that will be joined with the help of solid line. Next, even the triangular face O double dash 2 double dash 3 double dash is visible. Next, edge 1 to 3, that is 1 double dash 3 double dash, is going behind the observer, so that needs to be drawn hidden. It will be drawn with the help of a dotted line. Next, I'll make it dark. So here is the top view of that tetrahedron. Next, I'll give the dimensioning to it. That is 60 mm, and even this is the true length. I'll write here it is TL, which is the true length of this tetrahedron, and that is 60 mm. And once we have reached up till here, we can say that the problem has been completed.